Now, pay attention to this. Most dangerous viruses have an evolutionary trade-off. They either spread very easily or they kill too quickly. Nipah on paper shouldn't work well. It kills too efficiently. So why are experts still concerned? Because the problem isn't what it is today, it's what it could become. But before we get there, we need to talk about something almost no one mentions. Every time Nipah reappears, it follows a strange pattern. Bangladesh, India, specific regions, rural communities, indirect contact, not global explosions, just small fires, controlled but recurring. And this creates a false sense of safety, because psychologically humans have a powerful bias. If something doesn't grow fast, we ignore it. But viruses don't operate on human urgency. They operate on accumulated probability. Each outbreak is another genetic roll of the dice. Mutation after mutation, attempt after attempt. And here's the critical point. Nipah has already shown human-to-human transmission, limited, rare but real. And in epidemiology, rare doesn't mean irrelevant, it just means not optimized yet. Look, this matters. Whenever a biological threat appears, we ask, is it spreading already? But that's the wrong question. The right question is, does it need to spread yet? Most pandemics don't begin explosively, they begin quietly. And Nipah is almost the textbook example of a quiet virus, few cases, high fatality rate, low media attention. It's the kind of thing that doesn't make headlines. Until it does. Now we're getting to the part that truly changes the game. Nipah targets cells in both the nervous system and the respiratory system. That combination is rare and dangerous, but the most unsettling detail is something else. There is no proven specific treatment. There is no widely available vaccine. Clinical management is mostly supportive care. Treat symptoms. By time, and time, in this case, is a scarce resource. On top of that, the incubation period can vary widely, from days to weeks. That creates a nightmare for containment, because someone can be infected without appearing infected. Sound familiar? Exactly. And that's why Nipah appears in internal pandemic risk reports. Not as an immediate threat, but as a strategic threat. Here's where psychology comes in. Public fear isn't driven by data, it's driven by narrative. And Nipah doesn't have an easy narrative. It doesn't explode. It doesn't travel fast. It doesn't create instant chaos. So it gets overshadowed by louder crises. But behind the scenes, it's still being studied, monitored, watched carefully. Because in science, the most dangerous things aren't always the obvious ones. They're the stable ones. Now let's add humans to the equation. Population growth, deforestation, urban expansion. Bats aren't invading cities, we're invading habitat. Every time that happens, the chances of contact increase. And viruses don't need intent, they just need opportunity. Another factor, unequal healthcare systems. Outbreaks tend to happen where resources are limited. Fewer tests, less surveillance. That doesn't create more viruses, but it creates more time for viruses to learn. And for a virus, learning means mutation. Now, imagine a hypothetical scenario with me. A small genetic adjustment. Nothing dramatic. Nothing cinematic. Just a subtle improvement in human-to-human transmission. Not an explosion. Not an instant pandemic. Just enough efficiency to sustain longer chain. That's what models simulate, not the worst case. The plausible one. And that's why the World Health Organization lists Nipah as a priority virus for research. Not because it will end the world, but because it tests our response limits. Yeah, this needs to be said clearly. This video isn't an apocalypse warning. It's not a prediction. It's not a prophecy. It's an attention exercise. The Nipah virus is a reminder of something uncomfortable. The next major crisis rarely announces itself clearly. It starts small, disorganized, ignored, and often only becomes obvious when it's already past the easiest point of control. Remember when I said there was one detail that changes everything? Here it is. The biggest risk of the Nipah virus isn't the virus itself. It's the pattern it represents. A highly lethal virus, animal origin, limited human transmission, persistent over time. That's not an exception. That's a trend. Nipah isn't the main villain, it's the rehearsal. So if there's one conclusion here, it's this. The future of pandemics won't be shaped by sudden events, it will be shaped by small signals, ignored for too long. Understanding viruses like Nipah isn't about fear, it's about scientific and social maturity. And maybe, just maybe, paying attention before the next headline is the difference between surprise and preparation. Look, let me start with something uncomfortable. There's a virus with a fatality rate that can reach 70%. It has caused real outbreaks. It's not new. And yet, almost no one is talking about it. And here's the strange part. Every time it shows up, scientists go quiet for a few extra seconds longer than usual. Here's the point. This video isn't meant to cause panic. It's meant to explain why the Nipah virus deeply worries the people who actually understand pandemics, and why it may be far more relevant than it seems. Stay with me until the end, because there's one detail about Nipah that completely changes how we think about future outbreaks. Let's start at the beginning quickly. The Nipah virus was first identified in 1998 in Malaysia. At the time, it looked like just another regional outbreak, distant, contained, local, but it wasn't. Nipah is a zoonotic virus, meaning it jumps from animals to humans. In its case, the main reservoir is fruit bats, bats that feed on fruit. So far, nothing unusual. Many dangerous viruses come from animals. The problem begins when you look at what happens after infection. Early symptoms look almost harmless. Fever, headache, fatigue, nothing that immediately raises alarms. But after a few days, the condition can progress into acute encephalitis, inflammation of the brain, confusion, seizures, and in many cases, coma. And here's the first disturbing detail. Some patients seem to improve, and then suddenly get much worse. That confuses doctors, that delays responses, and that costs time. Remember that. We'll come back to it.